do you have the gas pressure that you're breathing right now, the air? How do we have that if there's no container to contain it? 'Cause every example that I can think of, car tire, bicycle tire, soda can, you need the container to have the pressure. So that's what we ask people is, how do you have gas pressure without a container?
Oh, I don't know.
Well, I mean, we essentially have two options. We could send you on a goose chase to look for a demonstration, or we could just rip the band-aid off and tell you how it is. I think some people don't want to hear it, but when we just point blank, there is no demonstration. I would say that's a violation of natural law. High pressure moves to low pressure. You open the high pressure, low pressure. You need a container. So we're saying that's another reason why there's no outer space is because we're contained. The Earth is contained. And it's a weird, tough pill to swallow, but essentially outside is inside. So you might have to pinch yourself next time you go out there. But yeah, we're essentially living in a container. There's no outer space. But again, it's tough to hear that, and a lot of people, it sounds
So we're living in a container.
yeah. I mean, yeah, unless you can provide
like telescopes, right?
What else could it be?
What?
Yeah,
Who?
Well,
So if we're in a container, how come? Well, is it see-through or what?
Oh, no, hold on.
He told you. It's a natural law.
Yeah. We'll see the thing.
Do you know what is natural law?
I have no idea what's going on right now.
It's more about the antecedent to what is, right? So if you have the steak on your plate, you're not asking. You're not. Hello.
I can't understand you. Your microphone is really loud. Let me turn it down.
My microphone is loud. You know, there's a feature in this Discord that you can lower the volume yourself.
There's like 20 million people in this chat. Hard to find them. What the fuck?
Yeah.
So the antecedent to the gas pressure is containment. To have the gas pressure, a container is required, and that's how it works. It's not bots or imaginary why nots.
I have a joke about telescopes because I say that telescopes don't whisper in your ear. What I notice a lot of people do is they see what they see in the telescope and then they add a bunch of details that the telescope doesn't provide. Oh, I saw millions and billions of miles with my telescope. Well, no, hold on. You saw things in the telescope, but they didn't tell you that was millions and trillions and billions of miles away. You added that. So, like Jemsy pointed out, I think this is a great example. It's called an antecedent relationship. If I plop down a nice juicy fillet on your steak, no fake stuff, no tofu, this is actual steak. I don't have to show you a cow. You know it came from a cow. I don't have to tell you what it looks like. I don't have to tell you how many spots it had, what name, what color. It's from a cow, period. So the same thing we're saying with the gas pressure. You cannot have gas pressure unless you have the containment. I don't need to show you, you know, well,
the color of the cow, if it's a Chinese cow or a Japanese cow or American cow, you know there's a cow because there's a steak on your plate.
Steaks are always from cows. Air pressure is always due to containment.
Yep. So I know when you look up, you see dark and stars, and you were told, a nice little bedtime story that's outer space. Well, you take that away, it's just
the Glober. Some of the Globers argue, oh, there's a steak on the plate, but I'm not gonna eat it until you show me the cow that it came from. That's the Glober.
Stupid. Yeah.
This argument always comes down to gravity, though, right? Can we just address that? Because I know XD is probably not going to talk about that.
Gravity doesn't contain air. That's just a claim.
That's the claim. That's the claim, of course, of Globers. They'll claim it's gravity, but
I threw out
Yeah.
a place in this.
Just like steaks don't
Mhm.
hatch from eggs, and gravity doesn't contain air.
That's a good one, Central. Steaks don't hatch from eggs. I'm gonna remember that. That's a good one. Nice.
I'll be here all week.
I also have a I have a recording. I have a recording from Richard Feynman about the second law, and I have a little GIF here of the second law in effect. So we can see when we test this in real life that there's nothing stopping the gas from going up. And so I'll play Feynman.
Well, there are the three laws of thermodynamics, very simply expressed. Now let us look at some examples of spontaneous changes and see how they are accounted for in terms of the second law of thermodynamics. We'll take the simplest first and look at changes where only the entropy changes. Now, one, perhaps the simplest of all of these, is the expansion of a gas into a vacuum. I have in one of these bulbs some bromine, and in the other I have a vacuum. And if I open the tap between these two, you will see spontaneously the bromine rush from one to the other. Now that is the simplest change we can have, perhaps, because all that happens is a change in entropy. In this case, the expansion into a vacuum, nothing else is involved. There's no energy change, there's no temperature change, there's no change except entropy. So without the entropy concept, that would have been difficult to understand and difficult to account for.
Yep. I mean, it sounds complicated, but he's saying you gotta have the container. If you don't have the container, you're gonna have the pressure move from a higher pressure area to a lower pressure area.
How old is that video?
What is that, Drace? 19 something?
Why haven't they made a new one modern?
It's one of the natural laws. It's just called entropy. So this one's pretty set in stone, I would say. It's just a really good example. But I mean, you can see this with a can of soda, for example, right? If you take a can
That's
of soda,
proven.
leave it on the counter for a week, it's gonna go flat.
Yeah, it's gonna go flat. Yeah,
So it's basically saying that you have to have that container to have
it
the
won't
pressure.
taste nice.
No container, no pressure. So we're saying that since we have all this air pressure on Earth, we're breathing. Well, it's contained. And like our ops will say, well, gravity does it, but gravity doesn't do that. Gravity doesn't.
What do you mean by ops?
Our enemies.
Okay.
I'm just joking, but the Team Globe essentially is saying that, oh no, gravity holds the air in, but no, it doesn't actually. Gravity, like if you let go of a balloon, which direction does it go? Up. Not gravity's supposed to do what? Pull things down. So no, gravity doesn't hold air down. That's silly. You don't even observe that. So yeah, that's the third argument that we offer. The first one we talked about was your moving house, whatever, moving buildings. We don't think the earth moves, right? The second was the water. We don't think that water forms in the hills. And the third is we don't think that the earth is in outer space. So that's the trifecta for you.
Very cool.
Don't let the people on YouTube make you think we're talking about freaking guards at the ice wall and crazy stuff like that. That's all gap, bro. So that's what we get down about: gas pressure, rotation, or movement, and then the surface of the Earth. It's really that simple. So, and yeah, again, you're more than welcome to come by anytime. I might have to leave here in a few minutes, so I see some other legends in the panel, guys. Don't be shy. If you have questions,
I came originally to listen, but
hey, I know. Hey,
got dragged in.
This is like Dancing with the Stars, bro. We'll teach you how to do the.
I even got warned about it, but I didn't listen really. I got dragged right in.
So, no, we'll show you how to rock back and forth, man. We've done this rodeo a lot, so we can show you how it's done. But yeah.
I think other people appreciate you being here, honestly.
I agree. You've been a good sport, XD. So we appreciate you. A lot of people come in and have their emotions. They get triggered. No. It's like, well, it's gonna be okay. Like, you can disagree and still understand our point. It's like a game of catch. We're just gonna throw a point out to you and see if you can catch it, and then maybe you can return it and throw it back. So that's really all it is. So you've done a great job, man. We really appreciate you. I'll give you some extra rolls for your time here.
Thank you. Thank you for taking time out of your day to explain.
Hey, we're here 24/7, man, and you're the one who took time out of your day to come here. So
It's not time for me. I had nothing to do, so I just came on, just listen.
all right, nice. Well, like I said, this place is we're open 24/7, and there's a lot of people who are willing and happy to answer your questions. So if you do think of something like, hey, I heard this, or maybe someone DMs you and you're like, hey, they're all stupid, don't listen to what they're saying, say this, let us know. Hit us, bro. We got you.
What is your profession? The old friend. I brought more soldiers than you did.
That's fine, but that's not a citation. A reference is not a citation. Okay, so if you want to use these words, go find a reference for what they mean, and then bring us back the citation of what they mean. Thank you.
So, can you tell me why relativity says that it would be equal if the sky was moving or the Earth was moving? Sure. So, the definition of citation, a quotation from a reference to a book, paper, or author. And the definition of reference, number 2, is the use of a source of information in order to ascertain something. So I'd say those are synonyms. You disagree?
No, not even close.
Awesome.
Dude, have you taken any collegiate or university level courses?
Yeah, I have, but why does that matter? Are we in college?
Have you done references and citations? Well, have you done references and citations?
I'm sorry, I didn't know that I was currently doing a college course on flat Earth in this Discord server. So, can I not use synonyms? Is this like whoever said, what was it before? Someone said the
colloquial... A reference isn't a synonym for a citation, dude.
What was the colloquial term for space. Someone used a colloquial term for space instead of using the actual physics term of space, right? So am I not...
Why should they use a physics terms?
Well, we're at a collegiate level to debate right now, aren't we?
There's no debate. You're just flailing.
So we're not. So I can just sort of like give the references a wiki article that has a list of the actual copies of the scientific paper. I can do that, can't I?
Right. That's not a citation, though, friend. That's the difference. You're offering references while asking for citations.
To reference something is to point at some source of information, like a...
Right, that's not the same as citing it. That's not the same as citing it.
I can cite a reference, and I can reference a citation. Are those two sentences equal?
No, they're not.
So if I cite a reference, if I say, oh, my reference for this is my friend Jason X, who this is his phone number. And if I reference a citation, I say, oh, my citation is the one written by Jason something, here's his phone number. Is that not equal? This is just...
No, because now you're mixing categories.
Do you guys have any reason why Michelson-Pierce scale didn't show the Earth was in motion?
Oh, yeah, because they had to apply a mathematical transform to fit their bias in order to get the conclusion that they wanted.
My boy just realized he goofed up and tried to run away from his own little example.
No, I'm just tired of the semantics. It's pathetic.
It's not about semantics, dude. It's about earlier you were asked to cite something that you offered as a reference, and you just told people to just read it. And I was just pointing that out, that you're a hypocrite.
How? I read out the results.
Okay, look, fair enough. Okay, maybe you're not a hypocrite. Maybe you just are ignorantly think that references and citations are the same thing. We'll forgive you.
You haven't given an argument why they're different. You've just said, are you doing a course? And I said no. Do you want me to read out dictionary definitions again?
Dude. Okay, for example, if he asks you for a specific piece of information about something, right? And you say, I'll give you the wiki in total.
Yes.
You're referencing the wiki. Now, if he says, I want this specific piece of information, you go to the wiki, pull out the citation, give him the citation from the reference that has a specific piece of information. Those are entirely two different things. They're not synonyms.
You think that citation has some different meaning.
Dude, I just explained it to you. Very simply.
From or reference to a book, paper, or author. That's for citation. For reference, the use of a source or information in order to ascertain something. Provide a book or article with citations of sources.
Oh my goodness, dude. Dude, you're wrong. You're stupid. You forgot the word specific.
To specific. No, it says or a specific reference.
Oh, a specific reference.
Yeah.
Not a general reference.
Citation, definition.
Holy fuck, bro.
Citation from or reference to a book. So that's the noun definition for citation.
Yes, and where's that in?
This is used in the definition of citation. You understand that, right?
Dude,
citation from.
If you're asked for a citation, a citation is a specific.
Have argument for flat Earth.
Yeah, you already conceded down is down, and water's flat and level. Therefore, the Earth is flat. Welcome.
Tower bridges show that Earth is not flat and level.
How?
Quarry tanks show Earth is not flat and level.
No, wrong. You failed to provide the citation that you were asked for about the tow tanks, how they specifically measured curvature.
No, string line.
You failed to provide the citation, friend.
No, you just didn't like the citation.
No, you didn't have a citation. You just generally said the term string line, just as you did again now.
And?
Watch. Ask me how, just ask me in the reverse. I want to play role play so you can see how stupid it is.
Yeah, sure.
Ask me how to prove, or what proof I have that the Earth is flat. Ask me that.
What proof do you have the Earth is flat?
Lasers.
Cool. Do you have a reference for someone claiming that lasers show the Earth is flat?
I do.
Awesome.
I have an 120-page PDF and an accompanying documentary of the methodologies and the practical tests that they did. And I also have a citation from their document that says the WGS-84 model is not found in the field.
Great. Link that and I will read it. See how that works?
Okay, perfect. Now, let me, actually my friends are going to link it because I'm going to speak. So, links, FE Core, for my friends who are using the bot, and then exclamation point videos laser short, exclamation point videos laser long. The short version is a condensed version that you can watch, and then the long version is the long version, obviously, that you can watch when you have more time. Now, I'm going to give you the practical methodology because I'm capable of... Hold on, friend.
I wanted to... Oh, no, it's a PDF. Okay, we're all good.
Oh, my fuck, dude. Did I not tell you what was coming down the pike? I said a PDF.
But then you spoke about long and short videos, and I wanted the PDF.
Yeah.
I don't know if that was being linked as well. But someone linked the PDF.
Yeah, fair.
I do.
No, all right, good.
Where?
Oh, yeah, it's my turn to calm down, bro. Were you not on calm when you began? The answer is yes, so fair is fair. Yeah, anyway, let's move on. When you asked for a citation of the methodology that they used with the string to prove curvature over the distance, you weren't able to provide it. You didn't cite from the text, and you didn't articulate the methodology. You didn't cite it from the text, nor did you articulate the methodology. But I'll tell you the methodology from this laser test, right? If you want to listen, I'll tell it to you. But you can also validate it from the document. So this is actually multiple tests, culminating in the final biggest test of 25 mile sample size over water, right? So there's 14 or 17, I can't remember correctly. But the longest one they shot was 25 miles. So what they did is they set up what's generally known as a laser transit, right, methodology, which is you have a laser, you level the laser, you shoot the laser across, and then you use what's called a storyboard or a receiver that's at the same relative height, and then when it hits, you see where the laser hits, and then you can tell how off it is. We use this in construction all the time to level foundations, excavate, all kinds of stuff. Very practical methodology, very simple. So if you have the laser set up on one side, right, about 2 meters, 6 feet off the ground, and on the other side you have the story or the target about the same, 2 meters, 6 feet, right? The globe Earth predicts a differential between the off angle that the laser should continue into the sky if it's perfectly level and the target at that distance to be 90 meters, right? So in other words, the big hump of Earth curve water and the level laser, right, can't shoot through the hump of Earth curve water, so it shouldn't hit the target. It should go over the target by 90 meters. Now, when they set this up, right, they took into account the ambient conditions. They took into account the millirad divergence of their laser. They created, which is in the documentary, a very accurate aiming device and leveling system. And if you watch it, you'll see how precise it was, very precise.
Type of laser was it?
Well, you'll have to look into there. It's a big old laser. A laser sufficient to shoot 25 miles with a very limited millirad divergence.
Yep, I read that.
So sufficient to the task. And they might talk about the type of laser, because they actually had two. I think the first one failed or they destroyed it. But anyway, they talk about that in the thing. And they give the specs for it. So they did the test.
It doesn't matter. Refraction wasn't accounted for.
Says who?
Them. As light travels in a straight line through a homogeneous medium, light angles due to different refraction indexes in a non-homogeneous atmosphere. We calculate direction and amount of refraction to show how much laser beam deviation affects the measurement outcome. In a non-homogeneous atmosphere where the index of refraction increases with height, rays of sufficient small initial elevation angle of refraction.
Holy crap, dude.
Is proportional to the rate of increase of the bi-directional index of refraction.
Yeah, you just said they didn't account for refraction, and then they went on to say we accounted for refraction in the very text you just quoted from.
Yeah, but they accounted for it wrong. And well, actually, they didn't. So they're saying that it's a homogeneous through a homogeneous medium. We calculate direction amount of refraction in a non-homogeneous atmosphere with the index of refraction. Blah blah blah. This curvature is proportional to the rate of increase of the bidirectional index of refraction.
Yeah. Anyway, so they set it up. They set it up, and the laser hit the target. Okay. Now, you may claim they didn't account for this, they didn't account for that. That's fine. But at least they have a practical example of their methodology.
Here we go. This is because I've read through this before, actually. Here's the problem. So the lake was partially frozen, therefore walking along the beam on the ice or using a boat was not possible. There's no data on the ambient conditions along the laser beam were available. We measured the conditions at the measuring.
Yeah, which site, which shot is this? Which shot are they talking about?
I don't know. I'm just reading out of the text document for refraction conditions, the PDF.
Which test? Which test was it? What location?
Point of laser beam.
I told you there was about 14 or 17 different ones, dude. You can't just pick one at random.
Well, this is their heading for refraction conditions.
Oh my goodness, dude.
So they said when they measured refraction between the sun
which location? Which location?
Why does that matter?
Maybe because, listen, friend, maybe because over time and at each location they learned things and improved their methodology.
Then why wouldn't they add that in under the refraction category or subheading?
Dude, how many different shots were there? How many different conclusions?
Right now.
I don't know, dude. How about you read the whole entire thing? How about that?
Yeah, I thought so. You'd run away from this discussion because you don't actually.
I'm not running away from it. I'm asking you specifics about the thing, and you're not giving them. Bruh. Now, by the way, in the final 25-mile shot,
temperature was 2 degrees. The air at night was 3 degrees. Humidity is always higher the closer you are to the lake surface, which indicates a lower refractive index. They just assumed a low refractive index. They didn't actually measure one. The ambient conditions showed that the refractive index
which location?
was the two sides of the lake. So it didn't measure the difference across the lake. They just measured one side of the lake, the other side of the lake, and said, yeah, good enough. Am I wrong?
Yeah, maybe at that site that's what they did. But which site are you talking about?
The refractive, measurement number 1.
Measurement number 1.
Find the actual spots where like,
oh my god, dude.
Balance on Vallegos observation points. And
is it observation
laser position?
Yeah, is location number 1 the one where they state that the WGS84 model hasn't been sort of upheld?
No, that's just their first one they did, dude.
Well, that
anyway. He won't even make it onto the rest, dude. He's just going to look at number 1, say they didn't account for refraction curves, light.
It was still at 0 degrees in the air. The night was down to minus 11 above the air. Air temperature at the time of the measurement was minus 6. The ambient conditions showed refractive index were about the same at the two sides of the lake. So they're just on the same thing, two sides of the lake.
Yeah, so the point I was trying to make is that if it's the first measurement that doesn't state that the WGS84 model is invalid, then what they did there isn't relevant to this argument.
My argument was their methodology was incorrect because they didn't measure the refraction across the lake. They measured it from 2 points, the start and the finish. And if the beam was to curve, it would curve between the start and the finish, not starting at the start and ending
Fantastic.
at the finish.
So is that location 1?
Yeah, and location 2, they use the exact same methodology.
Is location 1 the, let's just call it experiment?
Stop for a second and listen to what I'm saying.
No, I'm not going to stop.
Location 2, and they use the exact same methodology.
I'm not going to stop talking, right? So the issue is that if they are not using location 1 as the quote-unquote evidence for the WGS84 model being invalid, then it's a waste of time to analyse the methodology there.
The second one did the same thing. All of their measurements, they just measured the temperature at the start and at the finish. They didn't measure the refraction between them. Do you understand that, Crypto? Do you understand what I just said to you?
Location 2 being used to invalidate the WGS84 model.
It doesn't matter because they use the same.
Fantastic.
They use the same way of calculating refraction in all of their experiments.
The conversation. You're just wasting everyone's time.
What did I just say to you, mate?
AI, I heard what you said, bro. It's irrelevant. AI, can you tell me which location was actually used in this argument in terms of the WGS84 model, and then maybe we can read that.
Oh man, the only one I was talking about was IDSIL, the biggest one.
Fantastic.
Calculation of third measure.